In the next example, we're going to verify that a given function is one-to-one. We're defining S to be the set of real numbers minus the element -1. So the entire real line with the exception of -1. And we define the function f, mapping S into real numbers, by this. And now you can see why I had to define S to remove -1 from the domain, as it's not in the domain of this function. If you plug in a -1, you get a 0 in the denominator, undefined. So we need to verify that f is one-to-one. And maybe I'll write down exactly what we're going to do. To show that it is one-to-one, verify that f of A is equal to f of B implies that A and B are equal to each other. That's how you prove a one-to-one function. So this picture is not part of the proof, but if we've got A there, we've got B there. Suppose we have this number here in B, f of A, and it's also f of B. Well, is that possible? If A maps to that number and B maps to the same number, it's not one-to-one. So therefore, what this is saying is that if f of A equals f of B, A and B have to be the same number. So this would be that case. Standard proof in proving that a function is one-to-one. Here's how you do it. Show that f of A equals f of B means A and B are equal to each other. Well, it's just going to take a little bit of arithmetic. We're assuming this is true. So f of A equals f of B. And we have to prove then that A is equal to B. Well, we know what f of A is. F of A, where's the function? I lost it. F of A is 3A minus 1 over A plus 1. And if f of A is equal to f of B, drawing an arrow there, that means, that implies, this is f of A, and here's f of B. And just using some simple arithmetic, when you have a fraction equal to another fraction, you know the cross products are equal. So 3A minus 1 times B plus 1 is equal to 3B minus 1 times A plus 1. The cross products are equal. Well, I don't see any simplification, so I'm going to have to FOIL everything out. 3AB plus 3A minus B minus 1. That's what I get when I FOIL that out, I believe. And this would be 3AB plus 3B minus A minus 1. I hope I did it right. We'll find out in a minute. All right, let's simplify this. Subtract 3AB from both sides, and that goes away. Add a 1 to both sides, and those both go away. And so what do we have? 3A minus B is equal to 3B minus A. So adding to both sides, I'll add A to both sides, and I'll add B to both sides. And I would get a 4A equals 4B, which implies A equals B, and we're done. We showed that f of A equals f of B. If that's true, then A must be equal to B. In the next example, I'd mentioned earlier that sometimes finding the image of a function is very difficult. You can list out a bunch of points, but it might be difficult to get the entire set. In this example, we are required to find f inverse. I'm sorry, the image of f, but it's going to be easier to find the inverse first. And I'll explain why. Find f inverse and the image of f, where f of x is equal to 3x minus 1 over x plus 1. Let me see if that's showing up on the camera. Barely. Okay, so I'll read it again. Find f inverse, the inverse of the function f, which is defined over there, and find the image of f. We're going to find the inverse first. So if this maps to there, I'm looking for the image. I want to know what this set is. I'm looking for the image of f. Let's say that's A and that's B. The way I'm going to find that is, since it may not be trivial, find the inverse function. The inverse function is going to map this onto A. Well, that's going to be the domain of f inverse. The domain of f inverse is equal to the image of f. Remember inverse functions? The domain of one is the range of the other, and vice versa. So I hope you remember how to find the inverse of a function. Maybe a while since you've done that. I think we do it in pre-calculus. I'm going to do it the way I teach my pre-calculus students, and I make a tweak at the very end of it. Well, 4 steps. The first thing I do is just write y instead of f of x. And number 2 is interchange the x's and y's. And now we can kind of see why we're doing that. Remember that the inverse function, the ordered pairs are just in the reverse order of the initial function. So x is equal to 3y minus 1 over y plus 1. Number 3 is where the work, where you have to do the work. It's the algebra. Now I need to solve this for y. All right, so here's where we're going to do a little bit of work. Solve this for y. So I'm going to multiply, get rid of this fraction, multiply both sides by y plus 1. And that implies, maybe I'll move to the right a little bit so I have a little more room downstairs. That implies xy plus x equals 3y minus 1. Let's get the y's on one side. So xy minus 3y equals negative x minus 1. I subtracted x from both sides, and I subtracted 3y from both sides. So now I can factor out the y on the left-hand side. Y times x minus 3 is negative x minus 1. These are arrows for implies. And finally, we get y equals, let's see, it would be negative x minus 1 over x minus 3, but I'm going to multiply the numerator and denominator by negative 1 just to make it look a little bit nicer. And it would be x plus 1 over 3 minus x. If you multiply top and bottom by negative 1, you get x plus 1 up there, you'd get 3 minus x on the bottom. And then what I tell my pre-cal students is, number 4, replace the y with f inverse of x. But I think for this, from now on, and in this class, I'm going to try to use the variable y. F takes x into y, the set A into set B. We think of them as xy ordered pairs. F inverse starts on the other side. It takes y's and turns them into x's. So in this case, x is just a dummy variable. So I would write, I think I'm going to put F inverse of y equals y plus 1 over 3 minus y. That's the inverse function. Well, we're not done. We did find this. So now the image of f is the domain of f inverse. Remember that picture? F takes A into B. F inverse goes the opposite direction, B into A. The domain of f is the image of f inverse, and vice versa. So it looks like the domain is all real numbers except for the one that'll give us a 0 in the denominator. So the domain of this, which is the image of f, domain of f inverse equals image of f, and that's all real numbers except for the number 3. So the two things I've circled are what we were looking for. And that's it for the second chapter. Second section.